What is going on, guys? This video is actually a compilation of all my queues and publish subscribe specific videos. So I took those old videos, fixed the audio because some of them had like a bad quality of an audio, and then recompiled them into one massive video. I hope you enjoy it. The message queue is a very useful backend infrastructure piece that allows for asynchronous and distributed processing and many other use cases as well. It is designed so that a publisher can publish a message to this centralized piece, so this is the software, the message queue, and a consumer can consume that message in a first in, first out manner. The goal here is every consumer, once that message is popped, that's it, it's gone from the queue. No other consumer can consume the same message, right? That's the trick here. As a result, building a message queue is very, very difficult and very, very challenging, because how do you guarantee that that message has been consumed once and only once by a given consumer? It's very challenging. Kafka, RabbitMQ, ActiveMQ, and others does things differently. What is going on, guys? My name is Hussein, and in this video I want to discuss queues and when to use the queues, message queues to be specific. Like there are other type of queues, but I'm not sure what are they. So I'm talking about RabbitMQ, ZeroMQ, Kafka. When do you want to use this in your architecture, and do you really need it, right? And that's the question here. You always have a question that, hey, do I really need to implement this in my system design or not? And I'm just trying to kind of assess that and help you with that if possible. So how about we jump into it? And if you're new here, guys, I discuss all sorts of backend engineering in this channel. So if you're interested, subscribe and like this video and share with your friends. So that's it. Let's just jump into it. All right. So what is a queue and when do we need to use it? And guys, if you already subscribe to my channel, you would see me repeat this over and over again. Any technology out there, any backend technology out there, it exists for a reason, and it exists to solve a problem. So I know that might sound cliche and makes just perfect sense, right? Just, yeah, of course it exists for a reason. And that also means that there's no technology just exists for the fun of it or because it's cool, right? You need to use it if that problem exists for you. You cannot just use gRPC because it's hip and cool, right? No, you should use it when you absolutely, the problems that gRPC addresses solves your problem, right? Addresses your problem. Same thing with a queue. So how about we talk about the actual problems with the queue solves? Back to the request response architecture. When I make a request to a backend, and regardless of the communication protocol that I use, whether it's TCP, stateful TCP, raw, or whether I'm using gRPC, again stateful, or whether I'm using a stateless REST architecture, that request requires some resources at the backend to be served, right? To be consumed and executed, that request. What does that mean? It means that request might be list to get all the employees, right? Or an update to do a booking system, right? It's like, hey, I'm gonna book this seat. That's the same thing, right? And this requires a finite amount of time of your server to actually process this. And we talked about the ways you can serve your request. And one way to solve this problem is asynchronous execution with a single thread. Like your server has one thread, and that thread just keeps working the problems that it has, right? So serving request, this is now it's listening to TCP connection. This is now doing that. That's how Node.js does it, right? Other web servers does it differently, multi-threading, multi-processing, right? Regardless, right? So Apache does it multi-threading, Node.js does a single thread, but it's asynchronous. And we talked about that. I'm going to reference the video here. I think it's here. Go check it out. But sometimes a single thread in a Node.js or multi-processing or multi-threading in a web server could not cut it, because you will quickly overwhelm that single server to execute all these requests, right? It really depends if that request is taking a long time to process. And if it does that, if that request is taking a huge amount of time, an unpredictable amount of time to process, then there are flood of other requests that is coming. I'm not talking about queues yet, guys, right? Just normal request response. There are a flood of requests coming and they are waiting. And when I say waiting, the client is actually just blocked because that access to the TCP connection didn't even get a response back. Okay, and that could be harmful for the user experience, right? The user will feel it. So, ooh, what is going on? I click and nothing happened. And users hate that. When they click and nothing happens, you show me something that happens or tell me that something is happening, but don't tell me that I'm doing something and I did something and I don't see any results. They hate that. You're a user. You probably seen that. So how do we trick that? A normal request response architecture doesn't cut it in this case. If your response time is unpredictable, right? Because you have a lot of requests coming and you might say, hey, Hussein, I'm going to scale horizontally, and that's absolutely fine. You can do that. You can put a reverse proxy, have it configured to be a load balancer, and swizzle the request to all the other services. And if you've started seeing requests taking a long time to process, right, then you start spinning up more services or containers if you're in a microservices architecture, and then start serving that. And people do this to this day without a queue, without the idea of a queue, right? And as I said, this doesn't really scale well if your processing at the backend is very hungry, processing hungry, or CPU hungry, or even RAM hungry, because you're gonna spend a lot of time just having this process take time. So if you're predicting that responses will always take a long time, probably spinning up multiple services will not help you, right? Because the request will be the same, whether it's going, it's sending to another server which is free, or a service that is doing other things as well. Yeah, you're gonna still see some minuscule, is that the right word? Minuscule difference, but still, it's gonna take a long time. So here's where a queue is useful. If you really think that request will always exponentially go large, yeah, maybe if your database doesn't have any rows, but as you grow large, that request will go slower and slower and slower. It's just exponentially, not necessarily exponentially, just polynomially with your number of rows. So here's where queue really beneficial. So what you would do in this case is, here's what I'm gonna do. I'm gonna employ a queue in my system, a message queue. And that means if I am receiving a request to the server, I will do a very quick operation that is constant. That is a big O of 1. It's a very fast operation. And I'm gonna respond to the user with some sort of an identifier, right? And that's how a queue works. So if you send me a request, I'm gonna put it in a queue. That's a big O of 1, because writing is always fast, especially if you're in a LSM tree kind of a database, right? And most databases now, especially write only, just write to the end, LSM, right? Log structure merge. You write it, and then you respond back to the user, hey, I committed to you, user, that I have received your request, and it's now processing, or it's in the queue. I can't promise anything else, but hey, I received it. Better than having a request that is not served, right? that is not just waiting. So check user experience better, right? Okay, I'm willing to wait as a user. Yeah, at least they received it. And now, really up to you as an architect. You can have the client come back and ask and poll, P-O-L-L, this task ID that we're given. You say, hey, how's this job doing? How's this job doing? How's this job doing? And once that response actually complete, the response will come back, say, hey, that job is done. Okay, you can now do whatever you want to do. That's one way of solving the problem. RabbitMQ doesn't do it this way. RabbitMQ does it the push way, right? Where it's just like a stateful connection. I forgot what the protocol that RabbitMQ uses, but it's a very elegant way of using channels. It's awesome. I love it. And I'm gonna make another video about this compared to HTTP2. The idea of RabbitMQ using channels, it's very similar to streams, and I don't know who came up with this idea before. Regardless, get back to the point. If I respond back, if that job is dequeued, right, or executed, that could push results back to the client immediately as they are received, right? So this way you eliminated the latency of waiting. Client is still technically didn't receive the result, right? Because you don't receive the result, but I can unblock the user experience. I can show some sort of a progress bar. I can give a better user experience. And I elevated the flood of requests on my server. Now I'm going to have a nice queue. Yes, it's a centralized system still, but it's a nice queue, and services can listen to this queue and start pulling jobs, pulling tasks, and execute and write it back to the queue, right? Very, very similar to a pub sub system, except the only difference between a queue and a pub sub, a queue is whenever you remove an item from the queue, it is gone, right? That service owns it. It is dequeued. Versus the pub sub system, you have a topic, or very similarly, right? The brokers have these topics, and the service can as infinitely consume the same item. Many services can consume the same item, right? But now each service have some sort of a position that remembers, oh, I consumed this. Yes, I consumed this. I consumed this. And the service optionally can have a way to go back and forth in the queue and the pub subsystem. So that's a very quick way of knowing how do you actually, when do you want to use a queue versus just a normal request process system and load balancing and all that stuff, right? So very quick, if your request is indeterministic, you don't know how long it's gonna take, a queue is probably a good idea for you. If your process is by nature long running, a queue is good for you, right? Just queue it and let other process pick up the work and write it back to the queue. Or if it's resource hungry, if by default your process backend processing is a resource hungry, it's a bad idea to have the web server itself do the work for you. The web server should do one job and one job only. It shouldn't process your stinking request. It should just respond back to web traffic. It serves web. It is a web server. It serves web traffic, and that's it. Don't let it process your prime numbers or do a very complex operations in the web server stuff. Try to separate concerns as much as possible. All right, guys, that's a quick video just to let you know the difference between when to use a queue, when to not use a queue. Hope you enjoyed this video. Subscribe if you like this content. Like this video if you like it. I'm gonna see you in the next one. You say, guys, stay awesome. Let's start with request response model. It's a very elegant and simple design that had been designed in the 90s, and the whole internet is running on this thing. It's very, very simple design. That's why it's popular. So you're a client, you're a web server, and the client makes a request. Let's say this is a GET request over HTTP. The client waits. The client is blocked. Now you can argue with that, whether it's blocked and cannot do anything else, right? Which is no longer true because we have asynchronous requests, right? You can make a request and you can do other stuff in the background. That's okay, right? Because it's just you make a request, you wait, and you don't actively wait. You don't spend any processing power waiting, right? You just make a request and forget about it, right? And then once the request comes back, you get back a content, and then you do something with this content, right? So that's the request response model. It's always the client initiating the request. There is no other way coming from the web server. Okay, and I'm going to reference a video here for the asynchronous versus asynchronous. So there are a list of playlists that you can go and watch that if you're interested to know more. All right, and where does this break? Is this perfect? Obviously, nothing is perfect. Let's assume you have this system where you want to upload a video. Let's say this is YouTube. And obviously, when you upload a video to YouTube, you don't just upload a video. There are a lot of stuff happening in the background. So you want to upload the raw video. YouTube want to compress the video because usually it's that raw MP4 file is very huge, right? You want to compress it. And after compress is done, you want to pick that up by the format service. You want to format it. And what does that mean? You want to produce different video ties for the appropriate devices. So you want to provide a video for mobile phones. So that's maybe 480 or 720 or 1080 or 4K. You want to produce different kind of content, right? Based on the viewing platform and provide that. And you want to also, once this is done, you want to notify subscribers. So how do you do that with just request response? Well, it's still simple, but it really breaks down if you think about it. So client makes a request, uploads that beautiful raw MP4 video, right? And it waits, right? It can do other stuff in the background, but still waiting, right? And then upload service processing that stuff. And then once it's done, it is waiting and it's making a request to the compress service to compress the uploaded video, all right? Okay, that make a request. Now the compressed video is processing, and when it is done, it is waiting and make a request to the format service and waits, right? So a lot of people are waiting. There's a chain of people waiting for this thing to get done. Format service is processing, producing all these 480, 720, and 1080, and 4K, and 8K. There's no 8K, right? It's a fad. Right. I don't know if that's true. Okay, format service is just processing that stuff. And then once it's done, it will make a request to the notification service like, okay, I'm done. Let's make a request to the notification service, which will notify all the subscribers, obviously, that, hey, we're done. This video is uploaded. Go and then the format service is waiting for the notification service. And you guys can't argue with this, like, oh, no, really, we can notify people once it's uploaded, right? No, really. You want to notify people when it's ready to be consumed. When it's here, it's not ready to be consumed, right? So, and that even get more complicated as we talk about it. All right. Notification service said, okay, I'm done. The first response, format service said, I'm done. Compress service, I'm done. So if people start unblocking, services start unblocking requests as they come in, and finally the client will say, ooh, done, uploaded. All right. Obviously, guys, put anything that breaks in the middle, the whole thing is broken. I'm sorry about that. Okay. So the whole thing is essentially broken, right? Once you put any obstacle and network error, the whole chain is broken and you don't know if this thing is finished or not. That's the problem we're facing with request response. If you're chaining multiple services, especially in a microservices architecture, that breaks down. Let's say we want to add another copyrighted service, and we want this to the copyright service, like to check the content for content IDs and check if there is like a copyright infringement, right? So you want to consume, the compressed service need to send the compressed file to both format and copyrighted. Oh my God, right? This topology gets really complicated real quick, son, right? All right, what's good, what's bad about this? Pros. It's very elegant and simple, yes, if you have only two pieces of software talking to each other, that's beautiful, and I still love that. But once you get into complicated scenarios, not really, right? It's elegant and simple, I love that. It's stateless, especially when you use HTTP. That's not really true for like request response like a database. Like database, you make a SQL, that's still request response. You make a update table where blah equal blah, that's a request. And then when you get a better result back, hey, 70 role updated, that's a response, right? That's still request response, but that's nowhere stateless. It's as stateful as it gets, right? HTTP and other is stateless. But yes, you can argue with that, but it is, if it's stateless, it's good because it's scalable, right? You can scale it horizontally, and that's a very overloaded word. I hate putting it there, but I have to put something in the pros section. Scalable here means that it is scalable at the receiver end, where you can duplicate the receiver if it's the same content, right? If it's the same, has the same functionality, you can duplicate it easily and you can scale it easily, right? Because it just makes the same request, right? You can put it behind a load balancer, and beautiful idea, right? Load balancer can just route requests to any service and just scales very nicely, right? But it's not really scalable in other terms, right? So scalable here is a very overloaded word, and I'm really mean about horizontal scalability of the same duplicated service. Oh my god, that's getting complicated. Okay, what was that? Cons, what's bad about this? Obviously, as we said, it's very bad for multiple receivers. The moment you start seeing a lot of receivers, a lot of consumers, you start really wearing yourself down, and yeah, things can go really wrong. The moment you insert anything in the middle, right, your architecture falls apart. Okay, that's why you have to start hacking things around. How do you hack things around, right? You basically introduce high coupling, so a lot of services start talking to each other, which produces a lot of high coupled services. So services start knowing each other, and that's bad. We want software to have social anxiety. We do not want software to talk to each other. That's bad in software. High coupling is bad. We want software to be as oblivious as possible about the whole system. High coupling, yeah, we talked about that. Client and server have to be running. You won't say, Hussein, that's just weird. Of course, I'm gonna send a request if the server is down. Yeah, of course, the client and server has to be running to communicate. Are you telling me there's something better than that, where the client can go offline or the server can go offline and still they can communicate? Oh, we're gonna see about that. All right. Yeah, so that's kind of a disadvantage. PubSub has this advantage. Still have my concerns about that, but we're going to talk about that. All right. So chaining, circuit breaking, retries, all that stuff that we introduce just to solve the problem of how can we guarantee that these topology of systems connect together, right? The highly coupled system can correctly talk to each other, right? We need to time out correctly. We need to retry if that didn't work. And that just put a lot of pressure on the service and complicate things even worse, right? And that is a problem by itself. It's not an easy problem to solve. Yes, service meshes take care of that stuff. Clients like Finagle on Twitter, that open source to Finagle, can take care of that stuff for you, right? If you make a request. But to me, still sounds like we have a very complex system. So I don't know about that. Right, yeah. A PubSub is a backend infrastructure piece that allows a publisher to publish a message to the system and multiple consumers to consume the same message over and over again. Example is, let's say you upload a video to YouTube. This video needs to be processed, needs to be compressed, needs to be checked for copyright violation and other stuff as well. So these are consumers, right? And they all gonna consume the same message, the video, right? Unlike a queue, where once that message is popped, nobody should ever see it, right? For job processing or asynchronous processing.
Pub subsystems are very critical and very difficult to build because how do you guarantee that every consumer have read the message at least once? It depends on your guarantees. Kafka does it differently, RabbitMQ does it differently.
All right, pub sub to the rescue. It's the best thing ever. Not really. All right, so let's talk about PubSub. Publish, subscribe model. All right, we'll take the same example, the YouTube uploading service, and we're gonna upload a video, and we're gonna compress the video, we're gonna format the video, we're gonna notify people. How about that? So there is, as you can see here, you can see still the services here, the client here, the notification services, all that jazz. But there's some box here. This box is the middle layer that everybody's communicate to, and this is called multiple names. People call it broker, people call it message queue, people call it streaming processing, a lot of names, but it's a middleware layer where you can push and publish content to it, and it will take care of delivering that content to someone else, okay, based on the subscription model. So these guys subscribe, these guys publish, everybody can publish and subscribe at the same time. And you publish and you subscribe and publish to what is called a queue, or sometimes called topic, like Kafka call it topic, RabbitMQ call it queue, channels is called, I think, Redis call it channels, right? So by the way, Redis and Kafka and RabbitMQ, ZeroMQ, all of that stuff are just this message queue that supports PubSub, right? All right, let's go through an example. Let's see if this thing is good or not. All right. So here's the thing. Well, here's what I'm gonna do. I'm making a client. I'm gonna upload the service. Still, this is to an extent, this is still a request response, right? You can still mission mash. What does that mean, mission mash? I don't think it's a word. But yeah, you can do a hybrid between request response and PubSub, so that's okay, right? So you make a request, and upload service still processing, waiting for all your stuff. So the client is blocked now, right? And again, guys, when I say blocked, it doesn't mean he cannot do anything or she cannot do anything. Why am I referring to computers as gender? Okay, I don't know. All right, so you make a request and it waits, right? It still can do other stuff in the background, obviously, but it is asynchronous, nevertheless. So upload service, processing. Once it's done, the upload service will say, you know what? Just give me a second. I'm gonna publish this really quick to this topic. And once I get the result, and which is usually this quick because these guys are in the same network interface, I'm assuming this is another network interface and this is another network interface, so they communicate with this. I am hoping this is in the same, hopefully, a LAN area, and they will communicate whether like in a 10 gigabit Ethernet network or whatever, and that will become fast, right? So we make a request and then we'll get a response really quick, upload that 5 gig video. Once it's done, that's it. Your job is done as an upload service. So you can notify the client that it's done. Let's repeat that, right? All right. So upload. Once it's done, publish it to a topic or a channel and get back a result. And then shoot, upload it. Done. That's it. The client now done its job. You can disconnect the client. You can just move on with your life. The video is in the system and leave, right? Obviously, that means this guy has to be up all the time. That's what she said. But what we have here is essentially a topic. And that topic or the channel has the content. It's sometimes called a queue, a topic, a channel. And that has the raw MP4 videos. Now, how do people consume it? These guys would have been subscribed already to a topic that already exists. I just hide it. I did some animation. But compressed service in this case is subscribing to this topic. Now, we're going to talk in details like how this is actually done. What does it mean to subscribe, right? It's very weird, abstract word, right? Are you pushing the result to compressed service the moment you have a raw MP4 video? Or is the compressed service actually pulling information? Or is it like pinging? What's happening here, right? So you gotta tell me more, right? So the compressed service, there are multiple implementations. I'm gonna talk about them, but push and long polling and polling, just polling is just useless. I don't know why would you do that. It's just same as request response. But all right, so the compressed service will receive now the raw MP4 value. Let's imagine that it just got it, like immediately pushed to it, right? That has this limitation, obviously, but we're going to talk about that. The compressed service receives this raw MP4 video, start processing it, and guess what? It will publish its own compressed video to another topic that says, hey, compressed video, here is it. All right, it's a topic. So it doesn't really know who's going to consume it. The upload service didn't know that the compressed service is going to consume it. And that's the decoupling that we talked about. Blech. Just decouple that everybody from each other. The format service is now subscribed to the compressed video topic, and it will get it immediately. This is a little bit okay. Yeah, you get it, whether it's push or long polling, whatever. You get it. Format service, it's just like publishing content. Look at that. 480p, 1080p. This is Gary V, man. Format service is Gary V. Just producing content like there's no tomorrow. Format service publishes all that stuff so that it's done. Now, the notification service, let's say your notification, you want to notify people when the 4K video is ready. I know this is a little bit harsh. You want to notify people the moment the 480p video is ready. So it's up to you. You want, for example, to notify people when the highest quality video is available. That's going to take long time to notify people, obviously, but nevertheless, right? You got it. All right, and then you can easily fit the copyright service, right? We talked about just slam it there and subscribe to the, I don't know, the compressed video, and that will just immediately find any content ID and then there, right? So it's a beautiful design. Is it perfect though? I don't know. Let's find out. Pros. What's good about this? Let's find out. Obviously, it scales with multiple subscribers, right? Multiple receivers, multiple consumers. It's great for multiple receivers because you can add as many receivers and unique receivers here. We're talking about unique, different, distinct receivers, right? They are different from each other. They have different needs. They have different wants, and they want to be scaled. You can scale them beautifully, right? Unlike the request response where they have to be aware of each other, and that's bad. All right, so this thing is great for microservices, all right? It's amazing, right? Because the moment you have multiple services, in order to avoid the spaghetti mesh topology of everything is connected to everything, you can just have this one place and everything is connected to this place. Now you have a center, almost like a single point of failure, but that can be dealt with differently, right? We're going to talk about the pros and cons. Loose coupling, you just decoupled things. Now the services are not aware of each other. That's good. We like that stuff, right? The moment the less things are coupled to each other, the more they can essentially scale and be added, and the system can be modified easily, right? Because you can smartly change one thing without breaking the entire system, because coupling are bad. Because the moment you have a service that depends on 700 services, any small change can break any of these 700 clients, right? So if you're sure that your only client is the pub subsystem, you're golden, right? Works while client's not running. Well, yeah, but, right? So if we go back to the example there and we saw like the notification service, if any of these services are offline, we don't really care. The moment they come back online, they will subscribe and they will say, hey, we have a new message, we have a new topic, let's consume it, right? So that's okay because the message is already stored in the queue, in the topic, in the channel, right? So that's how, but that also means there's problems. Let's talk about the problems. Cons. All right, there are obviously message delivery issues. All right, so the message delivery issues about when we have a subscriber and we have a message queue, or we have a publisher and we have this message queue, and you're publishing something, how do you know that the queue, the message has been published. That's the first thing. Okay. Well, you can say that, well, Hussein, message queue will send me a notification acknowledgement. Hey, you're done. Good stuff. We're good. All right. And that you don't care about anything else for the publisher. That's good. Okay. If you don't receive the acknowledgement, you might try again, and that's a problem. Okay. Like, how do you know that if I published again, how do I know I didn't publish the same content twice? Right? We have ways of solving this with idempotency, but still, complication going on there, right? And who's taking care of this complication? Should it be me as a publisher, or should it be the message queue? I don't know. Right. The other problem is the subscriber. Now, the subscriber, that's the challenging part. How do you know as a subscriber that this subscriber, this consumer, this compressed service actually got the content first? How do you know that it actually processed the content? Because it has to tell the service, hey, by the way, I read this message. Just the fact that this acknowledgement that, hey, I read the message, people are taking PhDs in this because it's so hard, right? It is so hard to know that a message has been consumed or not. How do you know, right? You can send an acknowledgement, but what if the acknowledgement you didn't get it? All right, so we talked about the message delivery issues, obviously, and now let's talk about the complexity. It is a very complex system. Because of the message delivery issue, we try to find ways around it, okay? And to find ways around it, we add complexity. Okay, so it's very simple. Let's talk about the push and the pull and the long polling model. How do you deliver a message from the topic, right? How do the broker deliver a message from the topic to the subscriber or to the consumer, okay? How does that happen, right? You can imagine like RabbitMQ or Redis, and we made a RabbitMQ video here. I'm gonna reference it here, so you guys check it out. But it's very interesting. And what you want to do essentially is, first thing is you wanted to establish a two-way communication, like a TCP channel, right? And then RabbitMQ has its own protocol. I think it's not really its own, but it's a standard, it's an advanced message queue protocol. And they're using that, and it's a two-way communication, it's a two-way binary protocol, and they talk about it. Redis have its own REST protocol. I don't know what stands for what, but I forgot. So again, it's a two-way communication, where it's like you communicate on both directions. And then now you can start sending push messages as a result, because it's a two-way communication, right? And push messages, push notification, or push models, very complicated. It might sound nice. Hey, the moment I get a topic, immediately push to the subscriber. That sounds beautiful because it's almost real time. But what happens if the client is offline? What happens if the consumer is offline? You can say let's hold the message until they are online, and then when they are online, push it. Okay, that seems reasonable. All right, but how do you know that they are offline and then that status, right? You're almost keeping track of the subscriber in your message queue, and that might be okay if you think about it, but that adds additional complexity. Another complexity is the back pressure, where the publisher is so fast in producing content. Let's say a publisher is Gary Vee. It's just like grinding content daily, right? Not daily, every second, just publishing stuff all the time. And then the poor consumer can barely consume these messages. They are, right? There's just the flood of push messages. The little tiny device, for example, that consumes that stuff cannot handle that load. It just cannot. It cannot handle something that's shoved down their throat. Obviously, it's gonna wait, right? And what do you do with these awaited messages? Do you just put them back? And do you time out? Do you put them? Do you now keep track? Oh, this client is slow, so I'm gonna slow down. This client is fast, I'm gonna speed up. That's a very complex problem to solve by itself, right? That's a problem, right? And then another problem is Okay, so you might say that's the RabbitMQ and Redis uses that. Okay, that has its own limitation. So the other approach is to do like the polling method, right? Where do I have a message? Do I have a message? Do I have a message? As a client, you say, do I have a message? 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 Well, if you don't, then you just kind of saturated the network with empty requests, which kind of busyness, right? Right, that's a problem. Okay, that's a lot of processing wasted cycles for requesting empty responses, right? There's nothing for you, so why you keep requesting? So the solution, the part solution, is to use long polling method, which Kafka uses, right? Which is like, hey, you make a request and you block yourself, right? We're gonna block you, essentially, as if you made a request and we're taking a long time processing it, but there's really nothing to process. Nobody's busy. And because it's a beautiful of asynchronicity in this age, it's fine. You can wait, but you can do other stuff in the meantime. The only thing that's spent is memory here. That's the only thing I've spent. Maybe a little bit of an event main loop, just checking if there's something came back or not. But that you're doing that anyway, right? So it's not much. So the long polling, that's what Kafka uses, right? And then that has its also limitation, obviously, because like you might not get best real time, but you solve the problem of essentially the back pressure of shoving a lot of messages for clients who cannot be ready to consume messages, right? Obviously, it's a very complex system. And network saturation, in case of push, you're pushing a lot of messages, you're shoving the network with a huge amount of notifications and content, right? That's a lot of content going to the network. Sometimes unnecessarily, because the client doesn't really necessarily can process these messages, which might lead to failure, which may lead to you retrying. The broker can have to retry these requests, which is also bad, right? And then network saturation, on the other hand, is like the other way, underutilization, which I didn't write here. It's just like, hey, I make a request, but I don't see anything. I make a request, I don't see anything. So, summary, what did we discuss in this video? We talked about where the request response model breaks, right? It's a beautiful design, but it has its limitation, right? We talked about the pros and cons of this request response. We talked about the publish subscribe pattern or architecture. I don't know what you call it, right? Publish subscribe architecture or pattern, whatever rocks your boat. And we talked about the pros and cons of that thing, okay? The example of this is Kafka, RabbitMQ, and Redis. We made a video about Redis. We made a video about RabbitMQ. I am making a video about Kafka. Still in the process. I'm gonna let you guys know. If you want to really see the video about the Kafka, write down in the comment section right now, write Kafka, so we can actually, I see if there's a lot of interest in that. You guys give me a lot of great suggestions. I love those videos suggestion. I'm making them. I'm enjoying making all this content. It's a long form content. I know it's a lecture. This is not a 3-minute video that you will watch, right? And then you move on. This is videos that you watch if you're serious to learn, obviously. And no lecture, no 10-minute video can give you any value really, or 5 minutes video. You gotta watch and learn about a lot of stuff. Okay, that's the kind of content we make in this channel. So if you're interested, consider subscribing, like this video if you like it, and share it with your friend. I'm gonna see you in the next one. You guys stay awesome.